Our just-in-time inventory system is in fact working, and our last presentation of the day is imminent. James Barrett has joined us, and so we're going to take just about 120 seconds to make sure that we've got the tech support where it needs to be. Well, let me tell you a little bit about Mr. Barrett, and then when we're ready to go, we'll go right away. James Barrett joined Turner Construction as a co-op student in their Boston office over 19 years ago. And since then, he has explored and implemented innovative processes and technologies, including the early application of three-dimensional technologies for construction, an early adapter. Jim has held various positions in New York, Texas, Connecticut, and New Jersey. Recently, he was responsible for overseeing the development of Turner's national policies and protocols for the integration of model-based business practices, and as a result, Turner rapidly accelerated its adoption of BIM, having now over 350 projects representing more than $35 billion in volume that are either in construction or completed. And so he's come to us from New York today, but in a matter of minutes, I will introduce Mr. Barrett to you. So if you don't mind recharging your cups of coffee, I see there's a bit of a queue over there, and or talking amongst yourselves. We'll join you in just a couple of minutes. How was that? Hope you enjoyed your coffee. We're ready now to introduce boy, they're good. They're good. Right from New York, would you welcome, please, James Barrett. Here he is. Nice to see you, sir. Oh, it's all right, sir. Don't you worry. We're glad to see you.
I'm always cutting this too close. So I apologize for this. What I want to do is sort of give you an overview, not only of what we're doing, but why we're doing what we're doing. And I'll start with a story, which is sort of from my childhood, actually. Because my older brother, when I was younger, a teenager, had a car. He had a Mercury Cougar, which is shown up here. But it really wasn't the greatest car. And it was like a 1972 Cougar, and barely ran. And I always dreamed of getting that car and being able to fix it, and have this palatial machine that would impress all the ladies. And I mention this because at the time when I was a kid, you could imagine ignoring the fact that I have absolutely no skills whatsoever to do it, that you could imagine, though, that you could actually fix that car and work on the engine. But yet you look now at cars, and in fact, I had mine had to be serviced recently, and the technician said not even to think about touching anything in the engine because I'm going to mess everything up. It's all computerized. You got to plug it into their computers at the shop, and I say that because it's amazing, and we often don't see what's happening, that there's this evolution of technology, that things are changing. They're becoming more complex, more performance-driven. They're trying to squeeze out every last ounce of performance out of that technology, and as a result, it's necessary for it to get much more advanced. And you can see this evolution happening, and if you look at this graphic over, I found this a while ago. I think it's over like 80 years of new technologies, new innovations being introduced into the marketplace. Every line represents some technology. It could be a color TV or phones or what have you. What I find interesting and very instructive is the acceleration of the adding of the more lines in recent years, and the steepening of those curves, which means the adoption, which is from the bottom is 0%, top is 100%. More innovative technologies being introduced and adopted at a faster pace. You see this quick timeline right here we put together, which shows that the introduction and adoption of new technologies, how the time between them is shortening. Things are coming faster. And you see that, though we don't often realize it sometimes, we see it in the building industry just as much. I mean, buildings are as much machines as they are anything now, and they're becoming very complicated, complex. The software is allowing now new designs, but it's also affecting the building process. And yet, I think one of our challenges is that we're still trapped in a very traditional way of thinking. I get it all the time when we talk about the use of building information modeling in the company, from especially maybe older superintendents, project managers, or executives. They still always say, "Well, it's just we're still building brick on top of brick. Nothing's really changed for 100 years. All our buildings it's always the same," and yet it's not. And we're sort of we believe that we can take the same approaches that we've always taken, and this concept of the idea of the master builder, and there's going to be this sort of omniscient individual or entity that's going to be able to control the whole process and get it done with the complexity of buildings, the systems, the global supply chains. We're still working in very siloed, almost defensive postures, contractually trying to make sure that we don't bleed into somebody else or step into somebody else's territory and take on risk. And so again, we look at this way of thinking, and we say, well, if it's so good, why aren't we seeing better results from that, and why hasn't it improved over time? And an indicator of how that hasn't really improved comes from comparing to other industries. This is a study that was done by the Construction Industry Institute a number of years ago, comparing manufacturing to construction. And you can see that what's considered wasteful activities in that red, there's a huge difference between construction and manufacturing. There's a significant component of what we do would be classically considered waste, at least as defined by, say, some of the lean definitions of it. And you look at things like this, which is almost embarrassing for us to show, but again, this is not uncommon, and it's sort of amazing to think that, again, when that was installed, someone thought that was the best way to do it, that was the right thing to do, and yet clearly is not not right. And I'm sure you've seen this, but again, a chart of productivity over 40 years where you see this sort of mindset is inhibiting our ability to improve. The line at the bottom is the construction industry, and productivity is flat over 40 years, if not declined, and then every other industry has increased by twice what we have in terms of productivity. If you do something day after day, you're supposed to get better at it, and yet we're not seeing that improvement. I think that it's to some extent attributable to a failure to really recognize what we are doing and recognizing what's not working and finding ways to improve it. So what we're trying to address is how do we change that mindset? How do we change into some new paradigms of thinking? And BIM, I think, has become an interesting thing, separate from its technology. As we've seen its implementation broaden within our organization, what we've also seen is it's opening people's minds to the acknowledgement that there are better ways to do things, that in fact the traditional practices can be improved upon, if not discarded in some respects. And so it's become, though it's evolutionary in some respects of, we're going from, starting say in the design community where it was a hand drafting to 2D, and now we're going to 3D, and you could say, well, it's just sort of an evolutionary step forward. In some respects, it's become a revolutionary step forward because it's changed our way of thinking, and it's become that more, as I'm sure we've talked about today, a tool that enables a lot of new processes and new methods. The intelligence of the model now creates new opportunities to take advantage of that. New processes like a lot more prefabrication, modularization, looking at building systems a different way, and then what it's leading to, at least in our mind, is this idea when you again look at sort of more of a manufacturing template, that we want to look at construction as a production process. We're solving problems on the computer when it's cheapest and easiest to do it. When we get in the field, we're assembling the parts and pieces. It's an assembly, not a discovery process. We're not figuring it out for the first time, standing there with a set of drawings, wondering how does this all fit together. That's done. That's over with. We just show up and we say, let's build what we've already planned, and it's predictable and it's a known outcome. And so I bring up sort of the experience across the region. No, I don't mean it as to be boastful in any way of just the amount of work we have that's BIM, but more because it's illustrative of an interesting thing, which is we've never mandated the use of BIM on our projects. Never. There's no, our CEO hasn't come out with any sort of policy statement saying you must do this, or it actually started very much as a grassroots effort, mostly on sort of the West Coast, folks saying this is a better way to do things, migrated around the country and across North America, and now has grown to 350 projects, $30-some-odd billion worth of work, and I think that. It's interesting because this wouldn't have happened if there wasn't value there. We're in a tough business, tight margins. We don't spend an extra buck for the fun of it. We do things because we know it delivers. This happened because people saw that it was a better way to build. Made us better, made the industry better, and we just adopted it and went there because it adds value. So I think it's a great story of once you see that, you get up to the top of the mountain, you see the valley, and you say, this is a new way, this is a better way. It just takes off on its own, and it spreads. And you can see the value in terms of, again, when you talk about that chart I had earlier about productivity, in implementing, there's clearly is proven tangible value. This is a study we did of a number of projects, BIM versus non-BIM, and it was just productivity of MEP trades. And you could see there's a dramatic increase in productivity of those trades on a BIM versus non-BIM project. What this also proves is what we've seen, or validates what we've seen in the trade contractors, because they're in the same boat as us in terms of questioning whether they should adopt or not. And yet, as they've adopted, they've seen tremendous benefits themselves from a business standpoint. Again, they won't do this because it's just cool or it's a fun thing to do. They do it because there's a business value there. And this slide, again, is reflective of what we've often heard, which is that a BIM project is a better project for the trade contractors. They're more productive. They're more profitable. We're not sitting in the field arguing about changes and who goes where and why are we having all these issues. They come in, they lay out their work, they install it, and they're off and they're on to the next job. And in fact, we started seeing a bit of a sea change, or a tipping point maybe, in some recent projects where we had trade contractors on bid day would show up and they would have an add alternate on their bid if it was not a BIM project. So they'd essentially they discounted their number for BIM, and if it wasn't going to be, you had to add money to their number. So they were using it they were experienced, they were knowledgeable, they recognized the value, and they said, look, I'm going to use this as a competitive advantage. If it's not a BIM project, then it's going to cost more. It's going to start to cost more. And I think that's absolutely phenomenal, and again, a tipping point, because those competitors of theirs that aren't hearing the message, when they start seeing their competitors winning work because of it, then it wakes them up for no doubt. And in fact, we've now gotten to the point where it's our trade contractors who are pushing us. They're saying, we want this to be a BIM project, and if it's not, it's not as attractive to us. So I think it's taken some work, but there's now this recognition that again that this is a tremendously important new approach that is just becoming a part of our business, and so it also starts to change how we approach our work. And again, we look at not just the tool, which BIM is, but also the process, the workflows that changes, the relationships that are changing more. And truthfully, I look at it more as a problem-solving tool. it's not a software. It's a different approach, and so as a result, I have a broader definition of it, and this is a good example of it. So this is a larger project down at the World Trade Center in New York. It's about a $3 billion project called the Transportation Hub. Very, very complicated project because all the other World Trade Center projects link into the Transportation Hub. And so we were awarded the job probably 3 years ago along with a joint venture partner. And the first thing we did was we put BIM people down there. And they started modeling some of the components in different programs. They used ArchiCAD first, and then they tried Revit. But amazingly enough, because they had to produce models every day for the superintendents and project managers to understand the work, do constructability studies, they ended up going to SketchUp. And it's so funny because I talk to people and they're like, well, SketchUp's not a BIM program. And I'm like, well, who cares? The point is, I got a better tool to get the work done. If it's faster, better, cheaper, then why wouldn't I use it? And so we look at BIM in a different way. It's again more of a problem-solving process, and we'll use whatever tool is suited for the task at hand. I always say that we're software agnostic. It's whatever works at the time we're going to use, and so we try not to get too hung up on which software program we use. So we have a whole bunch of them. We spend a lot of money on software, unfortunately, but we have to. And again, you look at it as helping you in different areas. This is a healthcare study where we did mock-ups early in design of all the support structures above the ceiling, because there's a lot that people don't typically take into account, and you can plan for that early on because we know what that looks like above the ceiling. Estimating, applying it to estimating, taking quantities off the model. This is a brutal one. I will say, estimating has always been, it continues to be a bit of a tough nut for us to crack, because our estimating process is one that we're quite proud of and well developed over the years, and so we started early with BIM, and we tried to almost change estimating to fit what the software would allow, and I realized pretty quickly that was a mistake. We don't want the software to change the process, but we want the software to enhance the process. If we've got something that works well, don't disrupt it. Just try to make it better. And if the software doesn't work, change the software. And so we've been really working hard on how do you apply it reasonably and sensibly to improve what you're doing. And here's another example of just a sort of a conceptual level of estimating, where this is a great project because we'd met with the owner, it was a developer. They hadn't hired an architect yet. They only had a master plan. We took the master plan and we modeled the building as we thought it might look like based on our estimating historical data. It's going to be steel. It's a steel office building, 30 by 30 bay sizing because that's efficient. And then we just came up with different wall systems. This is a precast 6-foot spandrel. There was a 7-foot spandrel. There was brick. We did then a traditional, more of a straight curtain wall, and then a curtain wall with a brise soleil. They had a little sun shade for reducing passive solar, and then laid out the cost at the bottom and presented those to the owner and said, look, even early on, here's some parameters you can start thinking about in terms of putting your pro forma together, and sort of give some boundaries. What was fascinating, and it was a bit of a tipping point, I'd say, is that not a tipping point, but illustrative of what might be coming is the developer, and keep in mind it was a developer, turned to us and said, well, why do I need to hire the architect? How far would you go with this design? And I was in the room with a bunch of the senior managers, and I kept my mouth shut. I was like, I'm not answering that question. But amazingly enough, someone at a higher level in the company said, oh, we'll take it through schematics. And I almost fell off my chair. I was like, holy cow, we don't do that. We're a builder. We don't put designs together. That was one of those few jobs that I'm so glad it died, because we never had to live up to what we said. And actually, to this day, we work with that developer, and they still joke about that because they recognized they were asking us to sort of tread in new territory. But it is interesting. We don't want to take on that risk. We have no desire, but it was interesting. It was one of those moments when you're like, wow, maybe things have changed a little bit. And then again, the further use of that, once you develop that model, the further use for this case, that curtain wall procurement, we'll use it to show the scope to subs, more to verify and confirm scope and for the bidding process, not necessarily to rely upon, but just to confirm. For the most part, the models, whether we're building them or our designers are, no one's quite that confident in that it's complete and that it has all the parts and pieces and completely accurate that you'd expect that someone would bid on that. We're not quite there, and most of our subs are still not quite sophisticated enough that I think they'd be able to really rely upon it either. Here's another further use of it, which I think is interesting and probably really where everything should be going. It's using a tool called Celibri, which we like quite a bit, which is doing more of an analysis of the model based on rules. You set up rules. This is a code review of ADA compliance in the U.S. It's a wheelchair turn radius. And so you just set up a rule that for a wheelchair radius swing, and it just checks the model and says, in this bathroom, is there enough room for that? And if there is, fine. If there isn't, it actually sets up a flag and it says, hey, this doesn't match. The sustainability piece as well, where you can do life cycle studies and energy analysis. Amazing enough, we play around with those tools a little bit, not a tremendous amount, but just trying to explore them a little bit. Constructability reviews, where we'll take a slice of the building in design and just try to understand that how the system works, the parts and pieces. I always say that you can't hide in 3D. Either it works or it doesn't work. Either the information's there or it's not there. So we tear apart the drawings and try to figure out, does it work? All that slab edge coordination you got to do. Or even something like this, where amazingly enough, this is in SketchUp. One of our self-performed concrete groups put together a SketchUp model of all the formwork, trying to plan out the formwork, trying to plan out their pours, their lifts and such, and did it in a high level of detail. It's amazing. Logistics, safety planning, scheduling, we'll use it for, of course. This is one using a program called Synchro, which links it into the model, and then also at the top you see the cash flow. It's a big healthcare project. And then obviously, low-hanging fruit is where everything started, clash detection. I won't belabor that one. But it is interesting. Again, the clash detection is always one of those moments when, especially I've seen it for owners, when you go from that model and then they walk out and they see that the model represents what is installed. And then it starts to make them think about it. For an owner, at least, how do I further use this? And I'll show you some examples of how we've done that. And now I think one of the things we're really trying to push on is getting that model more out into the field, using it for layout, for instance, getting the points out of the model into a total station to get it to a layout. Even things like linking into barcodes and RFID for labor tracking, material, equipment, more advanced uses. But again, going back to that idea of the production, control of the process, knowing where everything is at any given point. Now we know what we're going to build, and now through the model, and now we want to make sure that it follows that. And then what's interesting, as I said before, is this, sort of opened this new mindset that of just general innovation. People start to say, well, what else can we do, and how much more can we push? And so we've developed sort of, almost by accident, what we call the voxel sort of suite of products, and this is one we call it Monitor. It actually links the model into a building control system live through a BACnet protocol on a project. We've got one project right now where we installed it, and it's on the owner's facilities management computers, where you can view the model, you can view all the sensor data that's coming out of the building. It's like we have 3,000 to 4,000 hard sensors and about 14,000 data points that come out of that, and we're getting every 15 minutes streaming out, linked into the model, so you can see the I don't know, whatever you want, temperature, humidity, alarming, all that information's now linked into the model, as well as all the project documentation and turnover. So again, we're trying to say, that model should never die. How do you keep it alive? How do you further use it? What are the more advanced uses? How do you help the owner be better at running their own operations? And so, it's a bit of a challenge because you got so many parties to this process, this life cycle process, and it really requires a great deal of that, again, that collaboration and integration, setting standards early on so that you're knowing, if you're going to use it for facilities, even starting in design, that it's being built and organized a certain way that it's going to be useful later. Otherwise, you can make it work, but it's more by brute force than elegance. I'll end with this a story more than anything, which more of a bit of a lesson learned for us, I think. There was this gentleman, Charles Proteus Steinmetz. He's the shorter man next to Einstein. He was an electrical genius at the turn of the century, and I don't know why. History forgot him somewhere along the way, and it's a shame because he was well known at the time. And there was a story, whether it's true or not, I don't know, but I love this story, which is Henry Ford approached him. Because Henry Ford had just opened a new plant, and he had a brand new generator that he bought and had tried to bring online, and the generator wouldn't start. Electrical generator wouldn't start for anything. So he went to Charles Steinmetz, and Charles, being well known as this electrical genius, said, "Could you come to the plant, help us, figure out why this generator is not working?" And so Steinmetz went to the plant, spent 2 days, 2.5 days, I think it was. Literally, asked for the plans of the generator, walked around it, took a hammer, was banging on it, blah, 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 went off, came back on the last day, and had a piece of chalk, and he drew a chalk mark on the side of the generator, on the casing, and he said, right here, remove 10 wraps of the coil on the inside of the generator, and when you do that, it'll run. And left, and lo and behold, that's what happened. They opened it up, they unwrapped the coil on the generator, and started up, and it ran. And so about a month later, supposedly Henry Ford got a bill from Charles Steinmetz, and it was a bill for $10,000, which at that time it was an unbelievable amount of money. So Henry Ford, being a cheap guy that he is, he went ballistic. And he wrote him back, and he said, how do you justify a $10,000 bill? You were here for only 2.5 days and walking around. And so the reply from Charles Steinmetz was in a nice letter, and he's laying out to Henry Ford. He said, and he itemized this bill, and he said, $1 for placing the chalk mark, $9,999 for knowing where to place the chalk mark. And my point of that is, use of BIM is a lot similar to that story. And they said, it's not just having the tool; it's knowing how to apply the tool, and the knowledge of where to apply it appropriately to get the most value. Because it can be, there's a lot of things you can do with it, but the question is it the best use for what you're trying to accomplish in the task at hand? And I think that's the thing that we've sort of that mindset. What we've learned is the smart application of the technology is a key, so that you don't end up spending a lot of money and time on something that's not returning the value. So I'll end it there, and actually look forward very much to the discussion that's coming, and would welcome if anybody has any questions. More than happy to answer them. Thank you.
Thank you very much.